All right, darlings, let's put it all together. Here you see 3 sets of charges. Each one, it's a repetition. I'm going to show you what kind of questions I can ask you about 2 charges on, let's say, a short answer test. The first pair. If I give you a pair of charges and I ask you to show forces between them, that means that you are only concerned with what they are doing to each other. In terms of they're both positive, so they will repel each other with equal and opposite forces. Hence, I'm going to just duplicate it. And there we go. Force, and I can say on 5 by 10, and this is force on 10. Second, what if I asked you to illustrate the field around them? Illustrate electric field, very important, around them. Did I pick a point? No, I did not. I'm just saying, what are they doing to the space around them? Remember, sunshine around the positive. Our electric field lines start in the positive and in the negative. If we don't have any end, they're just gonna stick out. And remember, they never cross, so you will have a little bit of action like that, coming out, coming out, coming out, coming out. And then you decide how elaborate you want to be. I'm just gonna go by 6. So I'm gonna have 6 lines around the 5, so therefore I'm gonna have 12 around my 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. This is illustration of electric field around the charges. Both of them are positive, hence the lines are coming out of them. Last one, I can ask you to give me a net electric field at any point around those 2 charges. And to make our lives easier, I would choose the smack in the middle. What are you going to do? You're going to illustrate the field at that very point, not around, at that point. Remember, we imagine a baby positive charge, 10 nanocoulombs, is going to repel it. This would be the electric field caused by 10 nanocoulombs. 5 nanocoulombs, because they're smack in the middle, is going to be half of that. And that's going to be E of 5. Then your E net, where you can write it as E net, is going to be E of 10 minus E of 5. And you're going to end up with newtons per coulomb for an answer. Well, let's throw in a number or 2. Make our life easier, I'm going to make this 2 meters. So then, when I'm figuring out my forces, I would use 899, 10 to the 9th. Then I have 50, 10 to the negative 18, and that over 4. And then you can use your calculator to figure out what that number is. Nothing to calculate around here other than the number of lines that you drew. And then finally, if I'm looking for electric field between these 2 charges, remember this is smack in the middle, so if that was 2 net, I'm going to subtract Kc over R squared for both of them, and it's just going to be Q10 minus Q5. If that does make sense, you can do E10 is going to be Kc Q10 over, if this is skipping too many steps, let's do it as step by step. E of 10 minus E of 5, net E is going to be Kc 10 over 1 squared minus Kc 5 over 1 squared. Notice how I'm not putting 10 to the 9th because I have not unveiled the Kc. Kc is 8.99, 10 to the 9th, and this is 10 and 5, both 10 and 5 are nanos, again for a reason. So then 10 times 10 to the negative 9 takes care of that, over 1 squared minus 8,995 10 to the negative 9 minus 899 10 to the 9th, 5 10 to the negative 9th, again cancels, over 1. So overall, it's going to be 899 times 10 minus 899 times 5, which is basically 899 times 5. 44.5 newtons per coulomb, and the direction you have to say is to the left. And if I did it straight here, 899 10 to the 9th over 1, 10 to the negative 9th, and then 10 minus 5, the same story, 44.5 newtons per coulomb. So if we're looking for forces, we're using Coulomb's law. If we're illustrating field around the charges, we just draw those lines. And if we're finding the value and the direction of electric field at a certain point, that's when you're going to do the E formula. And then one more question. What if I'm asked to figure out the net force on a certain charge? I can ask you for the net force on Q1, or for the net force on Q2, or the net force of Q3. And what you're going to do in those cases you're going to draw the vectors. So that's the set of forces between Q1 and Q2. Then I'm going to look at Q1 and Q3. I don't know the strength of the forces. I'm just generally drawing those vectors. They're always going to be equal to each other because it's a pair, action-reaction. And then finally, I haven't looked at Q3 and Q2. Q3 and Q2 are going to attract each other. So then you're going to go ahead and figure out your forces for each. And then for this one, you're going to say force of 2 minus force of 3, or force of 3 minus force of 2, depending upon which one of them is greater. And then here you would do force of 1 plus force of 2 because they're in the same direction. And here you will have force of 3 plus force of 1, and so on and so forth. So if you are looking for a net force on the charge, you will have to figure out the forces and then decide if you're going to be adding them or subtracting, very much like over here.